let's see if we can get the molecular structure for butyl, cyclopentane. So you would just break this up the way we've done it in the last several videos. The suffix is ane, so it is an alkane, all single bonds. So single bonds. It's pentane, so we're dealing with 5 carbons on kind of the base or on the kind of the backbone. So it's just 5 carbons. And it's a cyclopentane, so it's 5 carbons in a ring. So it's 5 carbon ring is the backbone. And then we have a butyl group added to that 5 carbon ring. Now you might say, hey Sal, how do I know which carbon to add it to? When you're dealing with a ring and you only have one group on the ring, it doesn't matter. Well, let me just show you what I mean. So let's draw the 5 carbon ring. Let's draw the cyclopentane. So it'll just be a pentagon. So 1, 2, 3, 4, 5. And then it's a ring, so you can connect them. 1, 2, 3, 4, 5. Now, it doesn't matter where I draw the butyl group. It's all symmetric around there. We just have a ring, and it's connected to a butyl group at some point. It'll start to matter once we add more than one group. So we can just pick any of these carbons to add the butyl group to. Now, just as a review, the but prefix, that refers to, remember, methyl, ethyl, propyl, or meth, eth, prop, but. This is 4 carbons. This is a four carbon alkyl group. So let me just add it here. I could have added it to any of these carbons around this cyclopentane ring. So if I just add it right here, so I'm going to have 4 carbons. So 1, 2, 3, 4. That is the butyl part of this whole thing. And then let me just attach them up. So you might be tempted to just draw this right there. And actually, this would be right. This is butyl cyclopentane. But a question might rise. I just happened to connect the cyclopentane to the butyl at this first carbon on the butyl right there. I could have just as easily done it like this. I could have just as easily had a I could have just as easily had it like this, where, let me draw my butyl again. So I have 1, 2, 3, 4. So once again, this is a butyl, but instead of being bonded to the cyclopentane on my first carbon, maybe it's bonded right here. Maybe, let me do it with that yellow color. Maybe it's bonded right here. Why, this seems like maybe this could also be butyl cyclopentane. It looks like we have a butyl group. This is butyl right here. I drew a butyl group right over here. And I also drew a butyl group right over here. But these are fundamentally 2 different molecular structures. I'm touching the first carbon here. I'm touching the second carbon over here. Now, there's 2 ways to differentiate this. One is the common naming, and one is the systematic naming. So let me differentiate between the 2. So in the common naming, and this can get a little bit involved. And this, frankly, is probably the most complicated or a part of naming organic compounds. Systematic is often more complicated, but it's easier to, I guess, systematically come up with it. So there's a common, and then there's a systematic. Systematic. So the common way of doing it is if you just say butyl cyclopentane, that implies that you are bonding to the first, or depending how you view it, the last carbon in the chain. So this right here is butyl cyclopentane. This right here is not just butyl cyclopentane. What you would do is you definitely have a cyclopentane ring. So this would definitely be a cyclopentane. Let me put some space here. This is definitely going to be a cyclopentane. And you do have a butyl group on it. So we do have a butyl group. But because we aren't bonded to the first carbon. We're bonded to a carbon that is bonded to 2 other carbons. We call this sec-butyl cyclopentane. So this is sec. And everything I'm doing is obviously freehand. If you were to see this in a book, the sec would be italicized. Or sometimes it would be written as S-butyl, butyl cyclopentane. And this sec means that we have attached to a carbon that is touching two other carbons. So you look at the butyl group and say, well, which of these carbons attached to two others? It's either that one or that one. And regardless of whether you're attached to this or this, if you think about it, it's fundamentally the same molecular structure. So that's what you do when you're attached to that guy right over there. But what about the situation? We're dealing with just the common names right here. What about the situation where it looks like this? So we have our cyclopentane right there. And we have I guess we could call it a butyl group. It'll have 4 carbons in it. But let's say that the 4 carbons look something like this. Let's say our 4 carbons. So we have 1, 2, 3, 4. 1, 2, 3, 4 carbons. And we're bonded to this one right over here. So whenever you're bonded to, I guess, one end of the 4 carbon group, and it branches off at the other end, and it seems a little complicated. And this only deals for alkyl groups below really 5 or 6 carbons. This we call an isobutyl group. So let me write this down. So this right here is sec-butyl, or S-butyl, sometimes for short. This right here, this right there, is isobutyl. It's actually iso. That is an isobutyl group. And then the last thing to worry about when you're dealing with butyl groups is something like this. So let me draw it. So you could also draw 4 carbons like this. You have 1 carbon, 1, 2, 3, 4. 1, 2, 3, 4 carbons, and you're attached over here. Now this naming, this group right here, and you're going to see the systematic naming is much easier for these compounds. This group right here, over here, the carbon you're attached to is attached to 2 other carbons. So it is sec-butyl. When you're attached to 3, it is T-butyl or Tert-butyl. So this right here is a Tert-butyl group, or sometimes called a T-butyl. And I really want you to understand the difference here. The common naming, it's easier to say and easier to spell, but it's sometimes a little confusing. This is just straight up butyl, so you would call this butyl cyclopentane. This is sec-butyl because you have this guy's connected to 2 carbons. That's where the sec comes from. Sometimes it'll be S-butyl. So this could be called sec-butyl cyclopentane, or S-butyl cyclopentane. This, because we're attached to the end away from this branching off, is still a butyl group since we have 4 carbons. But since we're attached here, this is isobutyl, so this is isobutyl cyclopentane. And then finally, since the carbon we're attaching to is attached to 1, 2, 3 other carbons, it is a tert-butyl, or a T-butyl group. So this is T-butyl cyclopentane. That's the common naming. So maybe I should clear out systematic here, just so it's clear to you. That everything we've done here is common naming. So let me write down. It won't hurt to write them down again, because the more familiar you are with these, the better. So this is just butyl cyclopentane. This is S, or sec-butyl cyclopentane. And this is isobutyl cyclopentane. I'm going off the screen here. And then finally, this is tert-butyl, or T-butyl cyclopentane. Now, I said these are the common naming. What are the systematic naming? Well, in the systematic, this is still butyl cyclopentane. So let me write this down. Systematic. This is still butyl cyclopentane, which makes sense. This is very clearly a cyclopentane. This is very clearly a butyl group. But the systematic naming, what we try to do is we try to name this group right here just as we would name a traditional chain, but we end it with an "-il". So if you look at this right here, what we do is we just consider the chain where we attach. So if you look at, we attached over here, so the longest chain from that point is there and there. So if you look at it like that, it looks like you have 1, 2, 3 carbons, and you have 1 carbon attached on the beginning. So this little group right here, in the systematic naming, this looks like a 1, 2, 3, 3 carbons. That's the prop prefix. So we're dealing with a prop, and it's all going to be one group. So it's a propyl group. This is a propyl group, but it has a methyl. Remember, meth is one carbon. It has a methyl group attached on the first carbon. So this is one methyl, one methyl propyl. Now that describes just the group. That describes one methyl propyl describes just this part right here. That describes just that right over there. And then to have the whole compound, to describe the whole compound, you'd put this in parentheses. So this is the systematic naming. So one methyl, I put an L there. Let me put it in the same color. One methyl, because you have you're starting where you're attaching. So one methyl, you have a methyl group right there on that first carbon. It's a propyl chain. 1, 2, 3. Propyl. And then you would say cyclopentane. Cyclopentane. That's the systematic name for that. Now, if you look at this one right here, what in the common name is isobutyl, what you do is you look at where we attach. Where we attach is 1, 2, 3 carbons. So once again, let me do it in that same 1, 2, 3 carbons. So once again, this is a propyl. Prop is for 3. But the methyl group now is attached to the 1, 2, the second carbon. So this is 2 methyl. Let me make some space here. This is 2 methyl. So that describes this group right here. That describes this entire group, cyclopentane. Cyclopentane. Remember, this is a systematic name. You might sometimes see this referred to as isobutyl cyclopentane or 2-methyl-propyl cyclopentane. And this is actually a YL. Spelled it wrong. And then finally, do the same exact idea here, but it becomes a little bit more interesting. Over here, we are attached to this carbon. And the longest chain I can do, starting with that carbon, is just one chain right there. So we just have a 2-carbon chain, right? 1, 2. The prefix for 2-carbon is ethyl, or eth. Eth, and since it's a group, ethyl. And then we have 2 methyl groups. We have two methyl groups attached right over there. And it's attached on the 1 carbon, right? This is 1, and this is 2. We call the 1 carbon where we are attached to the broader chain. So what this is going to be, you would actually write 1, 1 to show that we have 2 groups attached to the first carbon. And both of them are methyl. And so we write 1, 1 dimethyl. Di for 2. Dimethyl. So this entire group right here, which we also called T-butyl, when systematic naming, is 1, 1. We have 2 groups attached to this first carbon. 1, 1 dimethyl ethyl. That's this whole thing. This is the ethyl, and then we have 2 methyls attached there. That's why we write 1, 1. They're both attached to the 1. We have 2 of them. That's why we wrote di over there. So it's 1, 1 dimethyl ethyl, and then finally cyclopentane. Cyclopentane. So hopefully that doesn't confuse you too much. I think if you watch the video over and over and try to practice it with your own problems, you'll see that the systematic name way is actually pretty logical. And actually, if you have more than 5 or 6 carbons in the group, they always, or they tend to always use the systematic naming.